Sampling. We need to know some terms before we begin talking about sampling. First, population is each element or person from the set of observations that can be made. The sample is a subset of the population. A census is systematically getting information about an entire population. Sampling is studying a part or sample in order to gain information about an entire group. A sampling frame is the list of individuals from which a sample is actually selected. Types of sampling. A voluntary response sample is people who choose themselves by responding to a general appeal, such as calling into a radio talk show to voice your opinion on a certain issue, or calling in to cast your vote for a TV show. A simple random sample, or SRS, consists of individuals from the population chosen in such a way that every set of individuals has an equal chance to be the sample actually selected. A probability sample gives each member of the population a known chance to be selected. A stratified sample divides the population into groups of similar individuals called strata. Then, from those strata, we choose a simple random sample in each of them and combine them to form the full sample. In multi-stage sample design, samples are taken from various subsets of the population until a manageable number of samples to interview are arrived upon. Convenient samples is a non-probability type of sample where the sample is chosen based on their convenient accessibility and proximity. For instance, you just want to ask your coworkers. Statistical inference provides ways to answer specific questions from data with some guarantee that the answers are good ones. In inference, we must think about how to produce data as well as how to analyze the data. In an experiment, we will actively impose some kind of treatment in order to observe the response. In an observational study, the investigators observe subjects and measure variables of interest without assigning treatments to the subjects. We need to watch for bias when we're sampling. Voluntary response and convenient sampling are examples of bad sample design and can cause bias. The design of a study is biased if it systematically favors certain outcomes. Undercoverage occurs when some groups in the population are left out because of the process of choosing the sample. Non-response occurs when an individual chosen for the sample cannot be contacted or refuses to cooperate. Things to watch out for in interviewing technique. Response bias. When the interviewer's attitude suggests that some answers are more desirable than others, this gives the interviewer specific answers more often. Wording of questions. Confusing or misleading questions can introduce strong bias. In this first example, let's identify the population and the sample, and then describe the sampling method that was used. To conduct a pre-election poll on a proposed city ordinance, a random sample of telephone numbers from the city phone book was chosen and called. Assume all who were called answered. So our population would consist of our registered voters or adults in the city. Our sample is the people who were called. And since all who called answered, we can say that. Now, our technique was to use a simple random sample. Everyone in the phone book had the same chance of being called. So it's a simple random sample of the people in the phone book. Example 2. Determine if the study is an experiment where we impose a treatment or an observational study. A personnel director at a large company studied the eating habits of employees by watching the movements of a select group of employees at lunchtime. The purpose of the study was to determine the proportion of employees who buy lunch in the cafeteria, bring their own lunches, or go out to lunch. This is an observational study because there's no treatment involved. We're observing what's going on with the employees. Part B, a pharmacy student would like to know if there's a difference in results from a specific brand of drug and its equivalent generic prescription. She randomly selects 50 people who take the drug and has them complete a questionnaire regarding their symptoms and improvements after taking the specific brand or the generic equivalent. This one is an experiment because we're imposing the treatment. They're taking a specific drug. A random digit table can be used to help us select random numbers when we need to create our simple random sample or when we're trying to simulate experiments. On a table of random digits, we have line numbers to choose from, and then each line consists of random numbers grouped by 5s. And we can choose individual numbers, we can choose 2-digit numbers, whatever we need for our problem. For example, it's believed that 75% of all apartment dwellers in a large city deadbolt their doors in addition to locking them as an added precaution against burglary. Describe how you would select a simple random sample of 20 apartment dwellers to survey if there's 50 complexes and each complex has 250 residents. So what we would do is we'll have to number everyone before we start choosing digits. So we'll assign numbers to the complexes. So for each complex, they'll get a number, and we can do 00 to 49, or we could do 01 to 50. You just need to state what you're assigning first. And then with each complex, we have 250 residents. So once I've chosen a complex, we need to assign residents a number. And we can do 000 to 249 or 001 to 250. Our number of digits needs to be the same, so we can't go just 0 to 249 or 1 to 250. We need to choose the same number of digits each time. Now, there's a couple of ways that we could go about this. We could choose a certain number of complexes and then a certain number of residents from each complex. Or we could combine our results. For example, we could make these into 5-digit numbers where the first 2 represent the complex and the last 3 represent the resident. Either way, that would give us a simple random sample. Let's go ahead and do complexes. Let's choose 10 complexes and 2 individuals from each complex, 2 individual residents from each complex. So we'd go in the random digit table and we want to take 10 2-digit numbers. Now we can start at any line number. Let's say we want to start at 107. So I'm going to choose 80, 37, 65, 59, 98, and so forth. Now, for the numbers that aren't in our range, if we're doing 00 to 49, we discard the 80, we discard the 65, 59 is too large, so is 98. Next we have the 80, 0, 1, and we'd go forth and so on. 12 would be our next one. So for instance, complex 37 would be chosen first, and then our next two digit that falls in would be 0, 1, and then 1, 2. 72 would be thrown out, as would 76. Then 24 would be chosen. 07 would be next. 66 is thrown out. 49 would be chosen. And we'd repeat this until we get our 10 complexes. Then once we get each complex, we can move to another line, let's say 112, and we're going to choose 3-digit numbers. So from complex 37, let's say we'll choose resident 079. Then our next 3-digit is 658. That's too large. 975, too large. 496, too large. So a lot of times you go through an entire few rows before 559, then 464, that's still too large. 272, so you can see we're going to throw away a lot of digits before we find more that'll match up. Example 4. Bias is present in each of the following sampling designs in the situations below. In each case, describe the type of bias involved and state whether you think the sampling frequency obtained is higher or lower than the actual population parameter. In A, we have a political pollster seeking information about the proportion of adults who oppose gun control. He has a simple random sample of 1,000 adults and asks, do you agree or disagree with the following statements? Americans should preserve their constitutional right to keep and bear arms. A total of 91% agreed. The bias here would be the wording of the question. He's asking not just straight out about gun control, but about preserving a constitutional right, which when we're talking about American adults, it's something that they want to do. So this question needed to be reworded in order to eliminate the bias. Example B, a restaurant chain wants to know what percentage of American families go out to eat for dinner at least 3 nights per week. They call a simple random sample of 1,000 households between the hours of 6 and 8 p.m. and talk to 400 people. 300 of those 400 said they do not eat out 3 or more times a week. Well, the problem with this is they're asking about eating out, yet they're calling during dinner time. So most of the people that would be eating out are gone. They called 1,000 and only 400 talked to them as well. So there's also some non-response too.